has 6 sides, right? And all sides are equal, right? So we call in geometry cube is a solid 6-sided figure. But in case of algebra, how can we find cube? Right. For cube of any number can be find out as multiply this three number thrice. Okay. Now x is any number. So how can we find the cube of x? X into x into x. My dear students, all of you know that how can we find square of number? By multiplying a number itself, we get a square of a number. But whenever we find the cube of the number, we have to multiply that number 3 times. Okay, here the numbers and cube of the numbers are given. Now, 1 cube of 1 is 1. Cube of 2, how can we find cube? 2 into 2 into 2. 2 2s are 4 and 4 2s are 8. So, cube of 2 is 8. Cube of 3 is 27. Cube of 4. Cube is find out by multiply that number 3 times. 4 cube. 4 into 4 into 4. 4 4s are 16 and 16 4s are 64. Right? 5 cube 125. 6 cube 216. 7 cube 343. 8 cube 512. 9 cube 729. And 10 cube is 1000. Right? So, my dear students, you have to write this table in one notebook and recite the cube of the numbers from 1 to 10. Okay? So, look at here. There are only 10 cubes between 1 to 1000. Here the numbers from 1 to 1000. Okay? Total numbers from 1 to 1000. And there are only 10 perfect cubes, 1 to 10. 10 perfect cubes between 1 to 1000. Now tell me, how many perfect cubes are there from 1 to 100? You have to find how many perfect cubes from the number 1 to 100. Now look at the same table. Here, cube of 1 is 1. That means 1 is the perfect cube since it is a cube of number 1. Right? Cube of 2 is 8. So 8 is a perfect cube. Why it is perfect cube? Since 8 is a cube of 2. Similarly, 27 is a perfect cube since it is a cube of number 3. 64 is also a perfect cube since it is cube of number 4. Right? Now 125 is also perfect number since it is cube of 5. But 125 is a number which is greater than 100 and we have to find only the perfect cubes from 1 to 100 only. How many cubes from 1 to 100? Here. 1. Then 8, 27 and 64. Right? Since 125 is a number greater than 100. So there are only 4 perfect cubes from 1 to 100. And which are they? 1, 8, 27 and 64. So there are only 4 cubes from 1 to 100. Understood? Yes, this one is very simple. Now look at the cube of even numbers and cube of the odd numbers from the same table. Here 1, 3, 5, 7 and 9. 1, 3, 5, 7 and 9. All are odd numbers. Now look at the cube of odd numbers. Cube of 1 is 1 and 1 is the odd number. Again cube of 3 is 27. 27 is also odd number. Cube of 5 is 125 and 125 is odd number. Cube of 9 is 729. It is also an odd number. So from this we can conclude that yes, right, cube of odd numbers are odd. Correct? Cube of odd numbers are odd. Okay? And what about cube of even numbers? Here number 2, 4, 6, 8 and 10. These are all even numbers. Right? Observe the cube of even numbers. Cube of 2 is 8. It is even number. Cube of 4 is 64. It it is also even number. Cube of 6 is 216. Yes, 216 is even number. Cube of 8, 512. It is also an even number. And cube of 10 is 1000. And 1000 is even numbers. So, cube of even numbers are even. Okay, so you have to remember that cube of odd number is odd and cube of even number is even. Okay, understood this? Okay. Now, there is one question. Find the ones digit. You have to find the ones digit of the cube of the following numbers. Okay, here we have some numbers are given here and we have to find the ones digit. Okay, ones digit of the cube of this number. So it's simple. How can we find this? Yes. Look at this number. Our first number is called 3331. Right? And 1 is in the unit place. Okay. This digit or this number contains 1 at the unit place. Now you have to find out the cube of this number and the number or ones digit of the cube of the number. So, not necessary to find the cube of this number. Okay, only find the cube of the unit place of the given number. So here 1 is at the unit place, right? So find the cube of 1. Cube of 1 is 1. This implies what, or this shows that the cube of this number contains 1 at the unit place. Cube of this number contains 1 is at the unit place. Okay. Second example, 1024. For this example, here 4 is at the unit place. 4 is at the unit place. So just calculate cube of 4. Now what is cube of 4? Here 4 cube is 64, right? 4 cube is 64. And here in cube of 64, 4 is at the unit place. 4 is at the unit place. That means cube of the number 1024 contains 4 at the unit place. Just okay, I will explain you again. The number is 1024. It contains 4 at the unit place. So just take the 4 cube. 4 cube is 64 and in 64, 4 is at the unit place. That means if we take cube of this number, then that number contains 4 at the unit place. Okay. Next one, 149. For the number 149. Here 9 is at the unit place. So just calculate cube of 9. Now cube of 9 is what? 729. Cube of 9 is 729. So 729 and 729 is what? 9 is in the unit place. So cube of this number contains 9 is at the unit place. Okay. Now for the number 53. For the number 53, here 3 is at the unit place. Right? So take the cube of 3. Now cube of 3 is 27. So when we take or when we calculate the cube of number 53, we get 7 is at the unit place. So this is easiest way to find the ones digit of the cube of the number. Okay, just take or just calculate the cube of the number at the unit place. Okay, you have got the numbers or the ones digit of the cube of the number. Okay, understood? Yes. Now adding consecutive odd number. This one is interesting pattern. Just by adding consecutive odd numbers, we get the cube of numbers. Look at it. 1 cube is equal to 3. After 1, 3 and 5 are the odd numbers. So take 3 plus 5. Addition of 3 plus 5 is 8. And 8 is a cube of 2. After 5, we add 3 numbers. First we take only one number. After that, 2 odd numbers. After that, 3 odd numbers. So 3 odd numbers. After 5, 7, 9 and 11 are the odd numbers. So add these 3 numbers. 7 plus 9 plus 11 is 27. And 27 is the cube of 23, then 25, 27 and 29. Addition of these 5 numbers is what? 125, and 125 is a cube of 5. So adding consecutive odd numbers, we get a cube of numbers. Okay, we get cube of numbers. Understood? So this one is one interesting pattern, right? Now the most important thing of this topic is cubes and their prime factorization. We have learned prime factorization in chapter number 6, square and square root also. So just revise that fact. Now look at here. First number is 4. What are the prime factors of 4? Yes, 2 into 2. Okay, multiplying 2 with 2 we get 4. Now 4 cube. 4 cube is equal to what? Cube of 4 is 64. Right? And prime factors of 64 are 2 into 2 into 2. 2 into 2 into 2. That is multiplication of 2 6 times. So here we get triplet of 2. 2 triplets of 2. Here one triplet, another triplet. That means we can write this as 2 cube into 2 cube. Right? So look at here. 4 is the number that is 2 into 2. And 4 cube is equal to 64. Contains 2 cube into 2 cube. Right? Observe the one more example. Now the number is 6. Prime factors of 6 are 2 into 3. Right? Prime factors of 6 are 2 into 3. Now just calculate cube of 6. Cube of 6 is what? 260. Now just try to find out prime factors of 260. 260. So using this method, division method, we can find out here prime factors of 16, which are 2 into 2 into 2, 3 into 3 into 3. So we get one triplet of 2 and one triplet of 3. 2 into 3 into 3 into 3. Look at here. So 6 is equal to 2 into 3, but 6 cube is equal to what? 2 cube into 3 cube. Right? Consider one more example. Now 15. For 15, prime factors are 3 into 5. Right? Prime factors of 15 are 3 into 5. What is the cube of 15? 15 cube is 3375. 3,375. How can we calculate this? Multiplying 15 3 times. 15 into 15 into 15. We got the answer that 3375. Okay. Now just calculate here prime factors of 3375. Look at here. 3375. Okay. So here unit place of this number contains 5. That means what? This number is divisible by 5. Okay. So first we divide this number with 5. Here 5 6 are 30. 3 is remaining. Right? 5 6 are 30. 3 is remaining. 5 7s are 35. 2 is remaining. And 5 2s are 5 5s are 25. That is 675. Okay. 675. It contains 5 at the unit place. This means this number is also divisible by 5. So again we divide this number with 5. That means 5 1s are 5. 1 is remaining. 5 3s are 15. 2 is remaining. 5 5s are 135. Sorry. Okay. After that 135. 5 is in place. So again this number will be divisible by 5. So 5 3s, 5 2s are 10. 3 is remaining. 5 7s are 35. Right? After that, now 27, 2 plus 7 is 9. And 9 is divisible by 3. Correct? That means this number is divisible by 3. So 3 9s are 27. Again 9 is divisible by 3. 3 3s are 9. Again this number 3 is divisible by 3. 3 3s are 1. Now remainder is, here we get remainder is 0. Okay? So that means what? 5 5 5 into 3 into 3 into 3. So we write here prime factors of 3375 is equal to what? 5 into 5 into 5 into 3 into 3 into 3. So what we factorization of its cubes. Look at here. This prime factor 2. It occurs 3 times in prime factorization of its cube. These 2 also occur 3 times in prime factorization. For 6, 2 into 3. This 2 occurs 3 times in prime factorization of cube. Okay. Also look at here. 3 into 5. Here these 3 occur 3 times in its prime factorization. Also 5 is occurs 3 times in the prime factorization. Okay. So what is our observation? So note that each prime factor of the number appears 3 times in prime factorization of its cube. Each prime factor of a number appears 3 times in prime factorization of its cube. Understood? Yes. Now students, we are going to solve one more example here. First example is 243 is perfect cube? Okay, our example is what? Is 243 is perfect cube? Okay, so for perfect cube, just we find first we find the prime factorization of 243. 243. Now 243. 4 plus 3, 7. 7 plus 2 is 9. That means this number is divisible by 3. Right? So 3 8s are 24. 3 3s are 1. After that also 81 divisible by 3. 3 2s are 6. 3 7s are 21. After that 27 divisible by 3. 3 9s are 27. After that also 3 3s are 9 and 3 3s are 1. Correct? So what are the prime factors of 243? 3 into 3 into 3 into 3 into 3. Right? Now we are going to for that prime factorization of cube contains each prime factor 3 times. Look at here. So here we get triplet of 3. But for this 1 3 is remaining. Okay. Here we get triplet of 3 since each prime factor of that number appears 3 times in its prime factorization. Here and here this number, this 3 appears only 2 times. Okay, that means here we get only one triplet of 3. Okay, for this triplet we want one more 3. So that means this shows that the number 243 is not a perfect cube. Right? So we write here for this 3 into 3 we want one more 3. We want one more 3. So therefore 243 is not a perfect cube. 243 is not a perfect cube. Take one more example. Is the number 400 is perfect cube? 400. Just try 400. Just find out. 400 is what first? Here the last digit contains 0. So 5 8s are 40 and 5 zeros are 0. After that again it number is divisible by 5. 5 ones are 5. Correct. 5 ones are 5. After that 5 6 are 30. Right? Now 60. For 60 it is divisible by 2. 2 8s are 60. After that 2 4s are 8. After that 2 2s are 2. After that 2 2s are 1. Okay, that means 5 into 5 into 2 into 2 into 2 into 2. So what are the prime factors of 400? 5 into 5, 10. Just wait. 5 8s are 40. 5 4 0. After that, this one is 80. So 5 4 are 5. 5 6 are 30. And 16 is what? 20 20 22. Correct. So for this, we get here one triplet of 2. For this, 2 into 2, we want one more 2. Also here we want one more 5. So now tell me, is 400 is a perfect square? Yes. Since here triplet is not completed for 5, triplet is not completed for 2. So 400 is not a perfect square. Understood, my dear students? Okay. So for this session, today's session, we have learned how to calculate cube. Okay. Then cube of even numbers are even. Cube of odd numbers are odd. Also, we find out the ones digit of the cube of the given number and prime factors. Okay. Prime factors of cube of the number and their cubes. What is our observation? The prime factor or each prime factor of the number appears 3 times in prime factorization of its cubes. Okay. And one more type of example, how to find the given number is perfect cube or not. Okay. So using prime factorization, we can easily find out the given number is perfect cube number